Good morning, grade 5. Welcome back to grade 5 mathematics class. How are you all doing today? So today, let's learn the next strategy for problem solving. It's called work backwards. So where do we apply this? See, in some problems, we may know the final outcome or the final result of the problem, but we may not know the initial condition. So in such cases, where we know the final result and we are asked to find out the initial condition, we apply this strategy called work backwards. The key steps which we can use to work out this strategy are: first, you read the problem and then identify all the steps, whatever is given as input to you. Then you have to check the final outcome which will be mentioned along with the problem. Then you have to calculate each step after reversing the math operation. Then you have to find the initial answer. Then what is the final step? You have to test the solution from beginning to the end to verify your answer. So you have learned how to verify your answer when you are subtracting numbers. For example, 14 minus 6. We know it is 8. How do we check if the answer is correct? We can add these numbers, 8 plus 6. You add the difference with the subtrahend and check if you get the minuend. 8 plus 6 is equal to 14, and hence we will verify that this difference or our answer is correct. What if you are given a question like dash minus 2 is equal to 3? You know the final outcome or the final result, and you know the steps, but you don't know the initial condition or what should be put here. How would you find it out? So here in this case, you'll start working backwards, just like in this case. You'll start with the result and then you'll reverse the math operation to get the answer, which means you will add this 3 with this 2 to get the answer 5. So initially it was 5 and you subtracted 2 from it and then you got the final result as 3. So you read the problem, then identified the steps, you checked the final result or the outcome, and then you calculated each step after reversing the math operation. It means here it was subtraction and here you reversed the operation. You added the answer to this part to get the initial condition or the initial number. And in the final step, you tested your solution from the beginning to the end. So I hope you got an idea about this strategy. Now we'll see one example from your textbook. So you can see this problem in page number 212. Let me read the question to you. I had some flowers in my hand. I took a dip in the first tank and the number of flowers in my hand doubled. I gave 8 flowers out of what I had to the little girl standing on the bank and took a dip in the second tank. Again, the number of flowers in my hand doubled and I gave 8 flowers out of it to another little girl standing there. I took a dip in the third tank and again the number of flowers that I had doubled. But when I came out of the third tank, I found that I had only 8 flowers. I gave them all to the third girl. How many flowers did I have in the beginning? So what is mentioned in the question? How do we solve this one? We don't know how many flowers she had with her in the beginning, but we know in the end she had only 8 flowers with her. So we know the final outcome, but we don't know the initial condition. So from the final outcome, we are moving backwards. We are working backwards to find out the initial condition. So let's have a look at the question once again. So there was this girl and she had some flowers in her hand. With these flowers, she took a dip in the first tank. So after she took a dip in the first tank, the number of flowers in her hand doubled. And there was another girl standing on the bank, and out of these doubled number of flowers, she gave 8 flowers to that girl. So out of the total number of flowers she has now, she gave away 8 of them. Now she goes to this second tank and there also she is taking a dip. And then the number of flowers in her hand gets doubled. Now out of these flowers, she gives away another 8 to a girl. And then she moves to the third tank. And there also she takes a dip and there also the number of flowers get doubled. But she finds out that she has a total of 8 flowers with her now, and she gave all these 8 flowers to another little girl. So in the end, she was left with 8 flowers. From this data, we need to work backwards and find out how many flowers she had with her in the beginning. How do we do this? How do we solve this problem? Let's see how we can work backwards. So from the question, we know in the end she was left with 8 flowers. So these 8 flowers are double the number she had with her when she came to the third time. So can you say what is the number of flowers she had with her when she came to the third tank? It will be half of this 8. You see, these 8 flowers are double the number of flowers she had with her when she came to the third tank, right? So when she came to the third tank, what is the number of flowers she had? It will be half of this 8, right? So what is half of 8? We know it is 4. So she came to the third tank with 4 flowers. She took a dip and the number of flowers got doubled to become 8. So when she came to the third tank, she had 4 flowers with her, which is the number of flowers she was left with when she gave away 8 flowers from her hand. So at tank 2, she must have had this 4 plus 8 flowers. So what is it? 4 plus 8, that is equal to 12. So at tank 2, she must have had 12 flowers, out of which she gave away 8 to a little girl. Then she was left with 4 flowers with which she moved to tank 3. Now at tank 2, she has 12 flowers, which is the double of the number of flowers she had when she came to tank 2, right? So can you say how many flowers she had in the beginning when she came to tank 2? She should have had 6 flowers. So she must have had 6 flowers when she reached tank 2. She took a dip and it became doubled to become 12 flowers, out of which she gave away 8 flowers to a girl. And she was left with 4 flowers with which she moved to tank 3. Okay. Now when she came to tank 2, she had 6 flowers with her, which is the number of flowers she was left with when she gave away 8 flowers to a girl. So after taking a dip in tank 1, she gave away 8 flowers to a girl. So the number of flowers here would be this 6 plus that 8, which would be 6 plus 8 is equal to 14. So after coming out of tank 1, she had 14 flowers with her, and out of these 14 flowers, she gave away 8 flowers to a girl. So she was left with 6 flowers with which she moved to tank 2. She took a dip in tank 2 and the number of flowers doubled, and she has 12 flowers now. Now out of these 12 flowers, she gave away 8 flowers to a girl. Now she is left with 4 flowers with which she moved to the next tank, tank 3. Again she took a dip, the number of flowers doubled and it became 8. And she found out that she had only 8 flowers with her and she gave away all these 8 flowers to a girl. So we reached till this point. Now if she had 14 flowers with her when she came out of tank 1, what is the number of flowers she had in the beginning? It would be half of this 14, right? So what is half of 14? It is 7. So we have reached the initial condition. Let's check the solution. So in the beginning, let's assume that she had 7 flowers with her. She took a dip in tank 1, it doubled, became 14, gave away 8 of it to a girl. She was left with 6, moved to tank 2. She took a dip, it doubled. She had 12 flowers with her, gave away 8 flowers out of it to a girl. She was left with 4 flowers, moved to tank 3. She took a dip, it became doubled. She was left with 8 flowers. And she gave away all these 8 flowers to a girl. So see, from the solution, from the final outcome, we have found out the initial condition or the number of flowers she had in the beginning, and that is equal to 7. So children, this was one example of how we can solve a problem applying the strategy of working backwards. So I hope you have an idea of the strategy now. Now you may go through this topic, work backwards in page number 212 and 213 of your textbook. So once you have gone through the topic, do try to try this exercise which is in page number 213. So once you have done, you can take a picture and send us to Teams. So that's all for today, children. We'll meet in the next class with a new problem solving strategy. Till then, bye.